Hello, curious one! Have you ever wondered how we see in 3 dimensions? When we look into the distance, how can we judge the size and distance of objects, especially when one appears smaller but might just be farther away? Why do we see the world in 3 dimensions with depth, distance, and realism instead of as a flat 2-dimensional image? The most obvious answer would be our binocular vision, that is vision with 2 eyes. Each eye captures a slightly different view of the same scene. This is known as the binocular disparity. Our brain compares these 2 views and uses the small variations to calculate depth. This is the main way we perceive distance up close, and it is why closing one eye makes things feel flatter and harder to judge. But if our binocular vision is the main way of determining depth, how is it then possible to judge depth with only one eye? Surprisingly, our eyes aren't the ones doing the real magic. It is our brain. It acts like a detective, interpreting visual cues from the eyes to create the world we see. When we use just one eye, these depth cues are called monocular cues, and they rely heavily on experience, memory, and reasoning. All of this means that seeing isn't just something our eyes do, it is a collaboration between the eyes and the brain. Our brain doesn't just receive images, it combines them with what we've learned from years of experience. Without this learned understanding, we wouldn't be able to judge size or distance accurately and might constantly misinterpret the world around us. For example, a person who is far in the field appears to be much smaller than one who is standing in front of us. As we know, this is not because one is bigger than the other, but because one is closer and the other is further away. This is known as relative size. In addition to relative size, our mind also uses many other experiences or cues. Main of those are perspective, aerial perspective, also called fog trick, texture gradient, shading and lightning, motion parallax, also called the head bob effect, and occlusion, also known as overlap. An example for perspective would be when we observe railroad tracks. It would appear to us that they are coming together somewhere in the distance. We would take into account the width of the track and estimate the distance based on our experience. Also based on our experience, we conclude that the contours of close objects appear sharp, while distant objects appear somewhat blurry, a phenomenon also known as the aerial perspective. We can see fine details on a tile floor, but looking at the same floor as it goes off in the distance, those details become blurry, which means we perceive a changing texture gradient. We can read shadows and lighting with ease. They aid us in forming an idea of the shape, position, and size of objects. An object with a shadow on itself allows us to see it in 3 dimensions instead of as a flat surface. The distance between objects can also be determined by moving your head. Try it. Close one eye and move your head. Objects that are further away will appear to move with you, while objects that are closer will move in the opposite direction. This is called the motion parallax. Occlusion is simple. Objects that are closer often cover objects that are farther away. In this manner, it is possible to determine which of 2 distant objects is closer. In addition to these cues, there's also a physical clue your eyes provide: muscle tension. The closer objects get to your eyes, the more tense your eye muscles become as they try to keep it in focus. That effort is another signal for the brain about how near or far something is, especially within arm's reach. What we see is a best guess, constructed by the brain and based on visual input and prior knowledge, and not just a direct copy of reality. That is why optical illusions can trick us. They exploit the very rules our brain uses to make sense of space. This ability has been crucial to human survival. Correct depth perception helps us navigate terrain, avoid danger, and interact with objects. It is a silent, automatic process, yet incredibly sophisticated. The take from all of this is that you're not just seeing with your eyes, you are thinking in 3 dimensions. Our brain is constantly solving puzzles, making predictions, and turning flat images into a living, breathing world. And that, curious one, is one of the quietest miracles of being human. This was Captain Fact. Thank you for learning with me, and stay curious.